Hey guys, welcome back to another video. This is P3 Polynomials and Special Products. So as I mentioned earlier, poly means many, and when we are talking about monomials, that means how many terms. Nomials, that means how many terms. So mono means one, so when there is only one term, that is a monomial. Two terms is binomial, and three terms is called trinomials, right? So these are the basic things that we need to understand. Remember one thing, a polynomial written with the descending powers of x will be in the standard form. So what is the meaning of descending? That means from highest to lowest. X cubed followed by x squared, then x, and then the constant, right? So that is called the descending order. So whenever they ask for writing in the standard form, we need to follow that pattern. Let's understand this chart. So the first a, the highest power is 7, but it is not written in the descending order. So we need to write in the standard form, starting with the highest and then moving forward with the lowest. Now, one more thing, because the highest power is 7, so the highest degree is 7. And the term with the highest power, which is in this case negative 5x to the power of 7, has the coefficient of negative 5. So the leading coefficient implies the power, the coefficient of the term with the highest power, right? So 4x squared is not the highest, it is the second highest, right? So when they ask for leading coefficient, we always take the term with the highest power. The same with question number B. The highest power is squared, x squared, and the leading coefficient is negative 9. In number C, there is no x, but can it be written as x? Yes, because anything to the power of 0 is 1. So basically, we got 8 by 8 times x to the power of 0. Because x to the power of 0 is 1, I can rewrite it as 8. So the highest power is 0, and the leading coefficient in this case is just 8. Isn't that interesting? Okay, because with the beauty with power of a 0 is quite amazing. If someone asks you $1 million to the power of 0, they are just talking about $1. Now, expressions are not polynomials in two conditions: when they are under the radical sign, or when the variable or x term is in the denominator. So variable and inside the radical or in the denominator. So in the first case, we have radical 3x. X is in the radical sign. It is not a polynomial. In the second example, x is in the denominator. It is not a polynomial. So please write it down. Keep that in note when it will not be a polynomial. Now, operations with polynomials. It is just combining the like terms, because we are talking about subtraction in the first case. When we are combining the like terms, in my understanding and in my experience, I have seen students are able to calculate it more accurately when they write in the vertical format. So I wrote the first polynomial, the whole entire thing, on the top vertically. Now it is subtracted by 3x4 minus 4x squared plus 3x. Remember, we have a negative sign because it's a subtraction. I will write that down under the first polynomial, and then we can perform the operation. But remember, because the negative is outside, all the terms will change the sign. It is just like when I open the bracket up, it will change the sign. Negative 4x squared will become positive 4x squared. Now, let's do the operation. 7 minus 3, it will be 4x to the power of 4. Negative x plus 4 will be 3x squared. This will be 7x, negative 7x, and it is just 2. That's it. This is your answer. It is just combining the like terms, but when we have these big numbers, these big terms, it is my recommendation to write them vertically and then align all the powers. If any power is missing, just leave that column blank. This is called vertical calculation. Now, the second one, we are trying to find the product. So we can use a distribution. So I will write 3x first and the second term. Second term is 5x plus 7. So let's write it down. And then minus 2. And then followed by the second term again. Now distribute or multiply 3x with 5x and 3x with 7. That will give you 15x squared plus 21x, and I will follow the same pattern in the next one, negative 10x, negative 14. Now I can combine the like terms, 21x and negative 10x. So your final answer will be 15x squared plus 11x minus 14. This is your happy chappy lovely answer, right? So operations with polynomials. Let's talk about some special products. We have discussed it earlier and you have done this in Algebra 1 as well. So sum and the difference of the same terms. So u and v, they are same. One time they are added together, one time they are subtracted together. You might write, you can also write in the terms of a and b. So a plus b times a minus b will be a squared minus b squared. Now the square of the polynomial a plus b whole squared is a squared plus 2ab plus b squared. Whenever we are talking about subtraction, only 2ab will change the sign, right? Now the same thing with the cube of a binomial. So cube means to the power of 3. If you look at the pattern, there is an easy way to, without memorizing the cube of a binomial, you can write them down without memorizing. So if you look at u plus v whole cubed, it is giving you u cubed plus 3u squared v plus 3uv squared plus v cubed. This can be understood by something called Pascal's Triangle. Pascal's Triangle, we start with a triangle and we make the triangle with 1, 1 and 1. With this basic, we write the next sequence, next line by adding the 2. So 1 plus 1 is 2 and then followed by the wall. The walls are made by ones only. So the next one will be 1 plus 2 is 3, 2 plus 1 is 3, and then another wall is there. Now if you look at this, the second 1, 2 and 1 is nothing but the square of a binomial. So the first term, the first wall is u squared, the second, the coefficient is 2. So Pascal's triangle will help you to find the coefficient of the terms. In the cube, we are looking for 1, 3, 3 and 1. So that is the same pattern. If you have to find the fourth root, the pattern of the coefficient will be 1, 4, 6, 4, 1. So Pascal's triangle, if you know how to write the Pascal's triangle, you don't have to memorize all of these. The square of the binomial, cube, or the fourth root and so on. You can just understand the Pascal's triangle and you know what will be the leading coefficient, because the biggest mistake happens is when we miswrite the coefficients, right? So just follow this pattern, and the negative, it alternates. With u minus v whole cubed, we are starting with the positive. So positive, negative, positive, negative. It is a cube, which is odd. So it alternates. So few key things and it will be helpful. Let's take one example. Now in this one, we have the sum and the difference of the same term, the first condition. So based on the same first condition, so our pattern here is a plus b times a minus b, and I can rewrite a plus b times a minus b as a squared minus b squared. Now let's identify what is a. A is 3x and b is 4. right? So let's square it. 3x and everything squared. Don't just square the x. The whole entire term will be squared. So this will give you 9x squared minus 16. And that is what we are looking for. Let's take another example. Now we have 2x minus 5 whole squared. Now this is the square of the binomial. So if you have remembered from the Pascal, the coefficients are 1, 2 and 1. Because it is a negative, the second term will be a negative. So it will positive, negative, and then positive again. Whenever we have a negative, it alternates. The same thing that happened with the cubic, right? Cube binomial. So 2x everything squared minus 2 times the first term, which is 2x, times the second term, which is 5, and then 5 squared. Now let's simplify it. So this will give you 4x squared minus 20x plus 25. And if you remember this type of binomial, this is a quadratic. I hope this has been helpful. Thank you for watching and make sure to like and subscribe. I will see you in the next video. Bye-bye.